So you've gone for a leisurely walk along the beach and you've taken some absolutely amazing shots, but then you realize you've gone and set it to a ridiculously low resolution and all your images are coming out blurry. What do? Well, in this video, we're gonna take a look at how to fix that exactly. We're gonna take low resolution images and convert them into high resolution images using a pre-trained deep learning model. Ready to do it? Let's get to it. So we're gonna keep this one pretty lightweight from a technical standpoint. So if you are a beginner, this one should be a little bit easier for you to get your head around. Now, in order to do this, we are going to be leveraging a pre-trained GAN model from GitHub. Link should be up right about now. Now, in terms of leveraging this model, there's going to be a couple of key things that we do still need to set up. First up, we need to clone down the GitHub repository and bring it down to our desktop. We've then got to install a couple of dependencies, but then we'll be able to go on ahead and test it out with our own custom images. So you can take your own images, pass it through this pipeline, and have high resolution images generated from it. Ready to do it? Let's jump into it. So in order to give this tutorial a little bit of context, we're going to go and have a chat to our client and explain how it is that this model works and does what it does. Let's go and have a chat. Yo, Nick, I need to enhance some of my images. You got any AI that can do that? Sure. Have you heard of ESRGAN? Nope. Tell me more. Well, the model can take in a low resolution image and generate a high resolution equivalent using deep learning. This means that you can take all your sucky beach photos and make them look great. Interesting, but how does that work? It's built using an underlying architecture called a generative adversarial neural network, or GAN for short. So we have two neural networks, one generator and a discriminator. The generator tries to generate a high resolution image and the discriminator tries to pick it out and determine whether or not it's real or not. I don't quite get it. Imagine you've got a counterfeiter, right? He wants to create an image that looks identical to the real thing, but obviously it's fake. So he goes and creates this image and he takes it on over to a pawn shop to try to get a little bit of money for it. The store owner then tries to critique that artwork to determine whether or not it's real. This is exactly how a GAN works. The counterfeiter in this case is the generator and the critic is the discriminator. We feed in low resolution images to the generator so that it creates a high resolution image or artwork, and then our discriminator tries to catch it out. Okay. So how does the training work? Training is a bit of a balancing act. Now, historically, GANs have been notoriously hard to go and train. For the ESRGAN model, our generator is rewarded for generating images which fool the discriminator. So in this particular case, generating high resolution images which look almost identical, if not completely identical, to the high resolution equivalent of our training images. The discriminator in this particular case is rewarded for catching out those fake images. So here, high resolution images that aren't that good. Cool? Yeah, awesome. Let's see it. Let's do it. Welcome on down to the breakdown board. So in terms of starting out with this, the first thing that we're gonna need to do is grab some low res images. Now, let's say we've got some images of our beach scene. So how do we draw a beach? So let's add some sand. So set what sand, like yellow. Add a few waves and add the sun in the sky. Right, cool. So that is our low resolution image. So we're gonna take that low resolution image and pass it into our generator neural network. So that will effectively output a high resolution image. So this is what we're going to get as our output, which is pretty cool because we can take something which is a relatively small image, or say a blurry image, and bump that up significantly. Now, there have been a number of iterations for this specific model. So I actually tried to build one from scratch called ESRGAN. So ESRGAN stands for Enhanced Super Resolution Generative Adversarial Neural Network. Now, there definitely are other instances of this, but the nice thing about being able to leverage the one that we're going to show in this video is the fact that it is pre-trained. These are ridiculously hard to train from scratch. They require a ton of data, a ton of monitoring, and they can blow out really, really easily. So the fact that we can use this and it's all open source is absolutely amazing. So we're gonna take our low resolution image, we're gonna pass it through this network, and we're gonna get this as our output. Now you're probably thinking, well, how do we actually train this? Let's say if we wanted to. Well, first things first, you're gonna need a bunch of data, right? And that data comes in the format of low resolution images and high resolution images. Now, typically what you'd do is you'd get a high resolution image. So let's say this is high res. Add some mountains. So you'd actually take up that high resolution image and you'd actually make it smaller. So you'd actually convert that high resolution image to be a low res image. You then take the low resolution image and pass it through a generated neural network and learn to generate that high resolution image. And you'll calculate the distance between the real high res image and the generated high res image. We then take the generated high res image, which you can see here. Let's change the color of our arrow. And this will get passed through to our discriminated neural network. You can tell my discriminator drawing is getting significantly better. So that will be our discriminator. Now that discriminator is also a neural network. The thing is that discriminated neural network is going to take your output sizes. So whatever your output size is, that is going to be the input size into the discriminator. So this is actually taking in larger images and outputting a number, either 1 or a 0. So a real image, or whether or not it thinks it's a real image, or whether or not it thinks it is false. And that, in a nutshell, is how the ESRGAN model works. There are a whole bunch of other metrics in terms of the implementation and specifics in terms of the implementation, but at the crux of it, that is how that works. Let's jump on over to the tutorial and get this thing going.
Alrighty, so let's get right into it. Now, I've prepared a couple of steps that we need to go through in order to get this working. But namely, the first thing that we need to do is clone down the code. So this is going to allow us to leverage the pre-trained ESRGAN model. We're then actually going to download the model itself. So I'll show you which one to pick. We then need to install a bunch of dependencies and then we'll be able to get through to the good bit. But first things first, credit where credit's due. This model that has been made open source on GitHub is available by Xintao. So he's a researcher, he or she is a researcher at the Tencent Arc Lab, which is the Applied Research Center. Absolutely ridiculously amazing organization when it comes to deep learning and machine learning and advancements in AI. Now, the ESRGAN model that we're actually going to be testing out is amazing. These are some example results. So you can see there that is upsampling and producing ridiculously sharp images that perform or that look absolutely great. So we're going to be able to use this. Now, first things first, let's actually get right into it. So we are going to clone this down and then we'll go and get that model. So let's go and clone this. So I'm just going to open up a command prompt and I'm going to go into the folder that I want to clone it into. So I want to go into my YouTube. Actually, let's open up a full command prompt. So we are going to clone it into here. So we're going to type git clone and then the link that I had there. So it'll be git clone https://github.com/github.com/Xintao/ESRGAN. So if we clone that, that should start cloning it down. And assuming you have cloned it into the folder that you want to. So I've cloned it into a folder called, where is it? ESRGAN. Let me zoom in on that. So you can see that that is cloning over there right now. That is the folder. So let's wait for that to finish. My net always seems to want to go slow whenever I'm recording a YouTube video. All right, cool, we're done. So if we actually go and open that up now, you can see we've got all of our good stuff. So we've got our models and right now that's got nothing in there. So we actually need to dump in the trained model into there. And then we'll actually be able to test out our model by dropping in images into this LR folder. But before we do that, let's go on to step 2. So the next thing that we need to do is go and grab the model or the appropriate model from this particular Google Drive folder. Now that specific link is from the original GitHub repo. So let me show you where to get that just in case it does change. So if we actually scroll on down, you can see down here, there's actually links to download the pre-trained weights. So they're available from Google Drive or Baidu Drive. And if this does change, then it will be available in the Xintao GitHub repo. So just be mindful of that. Cool. So what are we going to go ahead and do? So we're going to go to that Google Drive link. So that's the one that I've got there. And you should be able to download the model. Now there's 4 models in here. The one that I've been using is this one over here. So RRDB_ESRGAN_X4. So if you go on ahead and download that, that should be, I think it's around 60-ish megs. Yeah, so 63.8 megs. So we'll let that download. You can see it's downloading down there in the bottom corner. Cool. So this is going to be pretty light in terms of coding today. We're just going to be testing this model out and seeing some of the results that we can generate, which is pretty cool. We'll give that a sec. Maybe I'll fast forward this in editing. Who knows? Booyah, that is now downloaded. So you can see it's now completed. So we can then go on ahead and grab that model. So it should be in download. So I'm going to cut that. And then you need to place this. So if this is my root folder here, right? So this is where I've gone and cloned down the model. So you can see it says ESRGAN. This is exactly what you're getting from GitHub. You just need to place that model that we just downloaded into the models folder. So I'm just going to paste that there. So effectively, you should have the GitHub repo inside of models. You've now got this rrdb_ESRGAN_x4.path model. Cool. So that is that all set up. So let's quickly double check our to-do list. So we've now cloned our GitHub repo. So that's done. We've downloaded our dependencies or downloaded our model. We now need to install our dependencies. So there's 3 key dependencies that I noted that I needed for this. So those were PyTorch, and ideally you want CUDA for this. So if you haven't seen how to install CUDA, jump on over to one of my TensorFlow videos. I show how to set that up. So we're going to need PyTorch and specifically a CUDA implementation. If you don't have a GPU, you should be able to try this out. Might just be a little bit slower. And then we're going to need OpenCV Python, so OpenCV2 and Glob2. So let's go on ahead and handle this first one first. So I've got a virtual environment set up here, so I'm just going to activate that. If you don't, that is perfectly fine. What's it called? It's called SuperRes scripts activate. So if you don't have a virtual environment, that's fine. You can skip activating that. You don't need to go ahead and do that. But now that we've gone and activated it, the first thing that we need to do is go on ahead and install PyTorch. So let's jump on over to the PyTorch website, pytorch.org. And then from there, you can just hit install. Boom. And then you've got this sort of wizard that you can go on ahead and click. So we are going to choose the stable version. My head's not covering that. So stable Windows. I'm going to use pip, Python, and then choose CUDA 11.3. If you don't have a GPU, that's fine. Just hit CPU. I believe you should be good to go. I haven't tested it out. So if you do get any errors, let me know in the comments. But for now, stable Windows, pip, Python, CUDA 11.3. So we're going to copy this command, jump back over to our command prompt, and I'm going to paste that in. So you can see that that is already installed. So if you're installing it for the first time, might take a little while, but this looks like it's saying requirement is already satisfied, requirement is already satisfied, requirement is already satisfied. So we should be good to go. Okay, what were our other 2 dependencies? So we need to install OpenCV Python and Glob2. So we can actually just copy this command here. So pip install OpenCV-Python and Glob2. Paste that into our command prompt. So let's clear this, make it a little bit clearer. Paste that in there. Cool, so that's installed already. So you can see no issues there. But the full command is pip install OpenCV-Python and then Glob2. So let's quickly take a look at our to-do list now. So we've done that, we've done that, we've done that. Can hit done. All right, now it's time to get this thing going. So the 4th thing is really all to do with testing this out. And it's kind of crazy how straightforward this is to get it running. So if we go into so we need to place our low resolution images into this LR folder, which you can see there, right? And right now we've got 2 images in there. And then we can run python test.py, and that is going to output our results into the results folder. Cool, makes sense? All right, let's try it. So I'm going to bring this over to here, and right now we've got the test image. So these are the sample images. If you see this image, this is a really common one that you'll see referenced inside of a lot of super resolution GAN papers. When I was trying to build ESRGAN, I actually picked that one up as well. Okay, but what we want to do is we now want to run that command. So first things first, we need to go into the ESRGAN folder, which we went and cloned from GitHub. So you can see that we are now in that. Cool. Then we can just run the test command. So in here, you can see that we've got this file called test, right? So you can see that that's there. So we just need to run that. So I'm just going to zoom out. Boom, boom, boom. All right, cool. Let's run this. So we can run python test.py. So you can see it's running right now. So model path. So it's picked up our model. It's testing the first file, which is a baboon, and the second file, which is a comic. Now, those results are now available in this results file. Pretty sick, right? Look at the resolution on this bad boy. So significantly better, right? So this is significantly larger. If we take a look at the other image, where was it? Low res. That is how small it was. How crazy is that? Even if I zoom out, we've gone from that tiny image to this. How amazing is that? In seriously, like virtually no time. The first time I did this, I was absolutely blown away. I thought that this was ridiculously sick. Let's go and grab some other images. So we can delete stuff that's inside of LR. Let's go and find some images. I'm thinking, what's the new Mercedes? What is it? W13? So this is the new F1 car. Let's grab this bad boy. That's already huge. Let's grab a small image. So size, let's go to medium. All right, so that's still big. Nope, big. Trying to find images that are a bit smaller. All right, let's copy this one. So I'm just going to save this image and I'm going to save it into that LR folder. So if we go into YouTube, ESRGAN, LR, so let's save it into there. And then let's run that command again. So right now in that folder, we've got the image of Lewis's car. Lewis? Yeah, that's Lewis. And then we can go and run this. So python test.py. So you can see it's picked up that file. So 526.44766, that's that file there. Boom, look at that. How cool is that? So if we go and take a look at our low res, look at the image difference. Like, I mean, this is upsampled. I mean, there's a slight little bit of graining there, but it has still gone and upsampled this with a ridiculous amount of precision. I think that this is absolutely phenomenal. That's actually how big the image is. That's without zooming. Nuts, right? How good is that? So easy. Let's go and grab some more images. I don't know. I'm consistently fascinated by this. I'm trying to think. So Sydney Harbour Bridge. Small. That's I've typed in small. It's returned an image which is 6,244 pixels by 3,112 pixels. Yeah, nice one. Okay, good. Ridiculous. All right, that one's small. Let's copy this one. So I'm going to save this Sydney Harbour Bridge image. So what is this? This is 555 pixels by 370. Let's actually take a look at the size of the upsampled Lewis image. So how big is this bad boy now? This is now 2,800 by 1,008. Let me zoom in so you can see that. So that image of Lewis's car is now 2,800 by 1,868. Crazy. What did we start out with? So if we go into low res. So it started off with 700 by 467. So how crazy is that? So what is that improvement? I think it's 4 times bigger, right? That would explain why it's called X4. So we've gone from, what is this properties? So we've gone from 700 by 467 to 2,800. Yeah, so 4 times bigger. Crazy how good that is. All right, let's try a Harbour Bridge model. So I'm going to delete the Lewis car. And again, if we just run python test.py, so it's picked up our Sydney Harbour Bridge image. Should get a result. Let's go into our results. Boom. How nuts is that? I am just amazed by how good this is. So that's our upsampled image. So if we go and compare to what we had previously, all right, so it's a little bit difficult to tell there because I've made them both the same size, but this is significantly larger. Like we can go way bigger. Crazy how amazing that is. Let's go and get like an old school image. I don't know what's trending right now. If I go to Reddit. I don't know. Let's just do more Formula One ones. So what's it called? Bahrain racetrack. What about this image? So this is 997 by 561. So if we go and save that one down, you could use any image you want, right? I'm just messing around and plugging in random images. But if we go and do this, so I've just gone and dumped in an image of the race. Right, and again, we can go and take a look at the results. That's gone and been upsampled. So again, ridiculous results. And like, I mean, you saw how easy it was. So I'll include these instructions inside of a separate GitHub repository with full credit to this GitHub repo because he's gone and done all of the work, or they've gone and done all of the work. But really, all we had to do was those 4 steps. So you clone the repo using git clone, download the model from Google Drive or Baidu Drive, install those dependencies, so PyTorch, CUDA, and then OpenCV, Python, and Glob2. And then it's literally that simple. So you grab the low-res image, throw it into the LR folder, and then run python test.py. You're done and dusted. Pretty cool, right? Relatively straightforward to get up and running. But on that note, that about does wrap it up. Let me know what you thought. Thanks again for tuning in. Peace.
Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a big thumbs up, hit subscribe, and tick that bell, and let me know what you thought of ESRGAN. Are there any other GANs we should be taking a look at? What did you think of the tutorial in general? Did you enjoy it? Did you get it working? Thanks again for tuning in. Peace.